Szanowni Państwo, czas zacząć pierwszą formalną część naszego dzisiejszego spotkania, czyli część techniczną, zatytułowaną Rozwiązania stosowane w badaniach jakości wód i gleb. Jako pierwsza wystąpi przed Wami Lori Chilcote, reprezentująca naszego partnera generalnego, Cox Colvin Associates oraz Vapor Pen. Ich produkty służą do precyzyjnego poboru powietrza glebowego w celu oceny intruzji zanieczyszczeń do przestrzeni, w których przebywają ludzie. Lori opowie nam, jak techniki GIS-owe w połączeniu z ich autorskimi rozwiązaniami pozwalają na precyzyjne szukanie źródeł zanieczyszczeń. Hey Lori, how are you doing?
How are you? It's nice to
Good.
see you.
Likewise. Finally.
Yes, finally. I'm glad
ready?
to be here. Thank you for having us. Dziękuję.
My pleasure. So the stage is yours.
Dziękuję. Thank you, everybody, for having me today. I appreciate your sharing your day with me. Let's talk about the soil gas sampling techniques for efficient site characterization and investigation to refine your conceptual site model. And to understand that, we first need to talk about the history. This is a map of the U.S. production of chlorinated solvents. In the 60s and 70s, it really reached its peak, making about 6 million pounds, which is 1 million drums of TCE. That's a lot of TCE. But if you think about it, an environmental manager with 30 years of experience has essentially no personal knowledge of how those solvents were used in bulk. And we were using them on everything. We were chroming things in industrial products and manufacturing, as well as dry cleaners. People came back and started dry cleaners. And we were using on painting and machining, medical devices. They were even using it to help women during childbirth, if you could believe that. So what were the disposal practices? They literally were being told to pour it on the dry sand or ashes, buried away from water supply. Even the ASTM standard in '62 said to just pour it on the dry ground. And that's exactly what they did. But to really understand your site, it's beneficial to have those conceptual site models. So let's talk about why we need a conceptual site model. What is a vapor intrusion conceptual site model? What data do you need? And what's next on the horizon? So a conceptual site model is basically your working theory of those potential vapor intrusion issues. They're chlorinated VOCs, petroleum, whether it be methane or mercury, and where are those sources coming from? How are they migrating into the buildings, and whether those receptors are commercial or residential? You have a plethora, a majority, a large vast of data sources, whether they be soil gas, ambient air, guidance, building or construction details. I've highlighted groundwater data in yellow because in theory, the screens are installed way too low to be beneficial for soil gas studies, so be careful. And don't forget about preferential pathways. If you think about the houses, the case study houses in the West and Midwest, they really didn't take preferential pathways into consideration, and now some of those results that they have can be questionable. Avoid limiting your COC list. If you only look for what you think may be there, that's probably all you're going to find. We'll go into that more deeply. So this is a standard conceptual site model, and what's next is you're going to take a look at where those sources are coming from, whether they're from the sewer line, whether they're from the crawl space, and if you go up into the house itself, is it coming actually from indoor source, whether it be something that's in your garage, such as a cleaning product or paint or glue, or is it actually coming up from the sewer lines themselves? Could it be indoor air or an outside source? But the most important thing is if you put your results on your conceptual site model, we are all visual, and visual can really help explain your conceptual site model. Let's talk about those innovative and proven methods. Again, expand your COC list. If you find a degradation CIS 12 DCE, you more than likely, especially in indoor air, you can pretty much assume that you have an indoor vapor intrusion problem. And as sewer gas, it's important to include those sewer gas constituents, such as brominated compounds, tetrahydrofuran, and chloroform, because if you find those, then you probably have a preferential pathway that you could mitigate and take care of your vapor intrusion problem. High-resolution sampling is a lot of data. The more data you have, the clearer picture your conceptual site model will provide. There's also multiple lines of evidence to take into consideration. All your potential pathways, Differential pressure is actually becoming a way to define when to take that perfect sample and consider weather and data seasonal variations. As I talked about visual interpretation methods, we took a lot of the vapor intrusion samples that we had done over the years and accumulated on this triangular graph. PCE is at the top, TCE is on your bottom right, and sewer gas is on your bottom left. We wanted to show that the indoor air and soil gas wasn't really being dominated by sewer gas. And if you take a closer look, you will see that, surprisingly, yes, sewer gas can dominate a lot of those samples. Again, use your conceptual site model to interpret the data because visual is very profound. Using GIS with historical data, this is a dry cleaner site that we took a look at. And if we only paid attention to the present location, we would have missed where the location actually started in the 1950s in the parking lot and could have missed a lot of the story. So what are the takeaways for these? Consider your preferential pathways, use high-resolution sampling techniques, make sure you go back and look at historical data, and expand your COC list. Visually put your data on a conceptual site model, but make sure you revisit it often so that you can update it as necessary. And for VI technology, we're going to talk about active sampling and mitigation. There are a lot of tools out there, whether you're going to use SUMA canisters, continuous monitoring, the flux chamber, or even vapor pins in a PID. And when you go into mitigation, there's lots of choices, vapor barriers. Just make sure you understand what you're trying to achieve so that you can choose the right tools for the job. So we're going to go into some case studies. Let's talk about source characterization. We went into this large building and talked to the environmental engineer on staff, and he indicated that PCE was the only solvent used on this site. He talked about the degreasers and the USTs and indicated this is where the problem was going to be. We had to figure out where to remediate it because it was either going to be torn down or they would remediate the site. Vapor pins were used to collect soil gas samples from 156 locations in 1 week. We couldn't go in at night, we couldn't go in during the day, so we could only go in at night. So we would install 30 pins, sample, extract, fill the holes, and come back the next day with clean pins to replay our job. We used a multi-gas meter to refine the conceptual site model to understand where our corridors and some plumbing was. We used PIDs, and we indicated that those contaminants were not in the areas originally suspected. And just as a reminder, those green patches are the underground storage tanks and the degreasers, and they were not where they thought they were going to be. So this was PCE. We took soil gas samples from each point, and using those PID readings, the subslab soil gas samples, this was PCE. This was TCE, and now they told us they'd only used PCE, so why were we seeing TCE? We thought it might be degradation. But upon going further and doing a focused soil sampling campaign, we determined and found DNAPL 15 feet below the surface, and there was a lot of TCE, so evidently it was used. Had we limited our COC list, we could have missed that. So again, don't limit your COC list. Then we went back to historical records and located and plotted the map on our conceptual site model. And as you can see, they did what they were told back in the 50s. They poured it on the ground, out the back doors, and that's exactly where the release occurred. For high-resolution sampling, let's take a look at that, how that can be effective. So this was a source of a vapor intrusion for a 60,000 square foot building. The previous consultant had evaluated it for 2 years and was unable to locate the source. They knew there was one, the building was ready to be sold and built out, and they couldn't find the source to be able to proceed with mitigation efforts. The yellow triangles are soil borings, and the red circles are monitor wells. So we screened and sampled 90 pins in 2 days, and we located this. We used the PID, and the samples were collected from each point. This was PCE, and again, the PID correlated very nicely. They didn't have any TCE issues, and this was TCA. So in 1 week, we were able to locate the source, allowing those mitigation efforts to proceed. So it's a matter of you get enough data, You plot the information on your conceptual site model. It's going to tell a clear picture, and you can do it in a cost-effective way. As a reminder, this is where the previous consultant had taken their sample, and it was groundwater and soil. If you're going to understand vapor issues, you need to take a vapor sample. It just will help refine it. Let's talk about a conceptual site model refinement. This is a picture you saw earlier. We took 9 samples of several houses in a neighborhood, from the sewer, subslab, indoor air, ambient air, the crawl space, and then we took and plotted our results on the conceptual site model. This is, and you can see PC is in blue, red is a TCE, and it looks very similar, that they, really that could be the sewer gas or the indoor air. But you add tetrahydrofuran, which is now in purple, you can instantly see that it was coming from the sewer gas on the left-hand side. Very visual and very effective. But what if we add tetrahydrochlorofluoromethane? Now you see that there is an indoor air source, and that is definite and defined and visually seeable on the conceptual site model. This is a due diligence matter. We weren't allowed inside the building, and they were going to, it was a multifamily situation, and they wanted to know if there was a problem inside, but didn't want us to go inside at the time, so we took samples outside in the parking lot. We installed a few and found a couple hot spots, used some historical information, and within 4 hours, we were able to determine that they did have an issue, and they went inside and were able to mitigate it right away. So with that, I thank you very much. I'm trying to be mindful of staying on time so that I can keep the situation going. Sebastian?
Thank you very much, Lori.
You're welcome.
Very inspiring.
Thank you very much.
I'll see you later for the Q&A.
Yes, thank you.